some conversation with Caren and Uwe. As we've done previously, I've been monitoring the chat, and I think Melanie might have left, but she was bringing up some interesting questions that were kind of discussed there. But maybe we can talk about her question about the thin, fresh layer of water at the top of the upwelling area, also contributing to trapping surface heat. I know Drew was commenting on that. Maybe Uwe has any thoughts. We could start there. If Drew and Uwe are here. And I'm trying to filter through the comments on the right because I know everybody's chatting a lot here. Unless anybody wants to pipe up and still has some pressing questions. I know Al was asking about the strong concentration of chlorophyll during Uwe's talk about how that modifies surface albedo as well.
Uwe, you have any opinions on that? You're muted.
You're on mute.
Sorry.
There we go.
We don't have measurements of that. Just visually, it looks, but that's just gut feeling thing. Like it would have a lot of absorbing characteristics. Not, I don't think, highly reflective. It was kind of murky, muddy appearance in the ocean. So I just. We would expect it to absorb heat, but as there was already mentioned in the chat and so on, and that's something we have been talking about repeatedly, we really should run some kind of mixed layer model or something to try to represent these processes correctly. The physical mixing, the albedo change, the insulation changes. I have a time series of incident radiation, which I could overlay on some of this, but it just was too much information to process and to show. But so there's more we can do and be more quantitative, and we definitely plan to do that.
Yeah, I'll jump in quickly. We have run some KPP models, a postdoc working with me, Tamara Schlosser, which is what we've got a little bit of experience with implementing the 1D models in other places where we have high resolution data like this. We actually did measure 4 different bands of subsurface irradiance that allows us to estimate the spectral distribution of light with depth, on profile to profile basis. And what we see is that the attenuation coefficient, the E-folding length scale of the penetration of the surface insulation is, a quarter of what it normally is. And our KPP simulations, we haven't tuned up enough to really match the observations perfectly, but they do show this sense of the fact that the bloom can warm itself. So, obviously it can't create stratification before the bloom exists. And that's what Uwe is talking about in terms of the role of potentially precipitation and other background dynamics adding together. But once it gets started, if it's sunny, it very much does, remove sunlight from depth, and that is to say, increase the heating of the upper ocean, and that's a synergistic or positive feedback for the stratification. So there's more to put that story together, but and then this is old. I mean, people knew very well in the 1970s that the optical characteristics of the ocean mattered to mixed layer models, and somehow we've been beaten down by the physical oceanographers, of which I'm one, that the biology cannot affect the physics. And yeah, when it comes to swimming jellyfish and turbulence, maybe that is or isn't right. But when it comes to attenuation of surface insulation that's entering the surface ocean, it is very much the case that the optical characteristics drive a lot of the mixed layer, the vertical distribution of the heat flux in the mixed layer. At times, it has to be pretty opaque. So it's high biomass regions, but anyway, sorry, I'll jump off my soapbox. But I think we can see the ability of the, or we can envision the interaction of the biology and the physics in this very shallow mixed layer scenario.
People have tended to pay more attention to it in parts of the ocean where the waters are typically clear or free of sediment. So the chlorophyll makes a bigger difference on its own. I think one of the reasons we didn't see as big of a difference as we might in the Bering Sea is because there's lots of gunk there in the water already attenuating the light. So chlorophyll's not the only. Yeah, but it's great stuff. I'm a physical oceanographer, but I never subscribed to the biology having no substantial.
Yeah, that's
on the record there.
A script-centric view. And to emphasize a little bit what Uwe said, or the measurements of nitrate on isopycnol, what we demonstrated in Toto, or the take-home message, is that the variability on an isopycnol at the depth of the nutricline is a 1 standard deviation of the variability. This is from measurements, right? Is the same size as the mean. And so we think about the nitrate density relationship as quasi-static, but in fact, it is very much, at least these observations show under these conditions, it is very much not static. And nor should it be when the sink for nitrate is variable. And so I think we have the ability to quantify productivity via uptake with a model. If you can get out of it, you can get advection out of it. And it was really empowering to see the crazy patterns of nitrocline, nitrate concentration, nitrocline gradient in depth, and the cross isopycnals, and the changes of those in time on time scales from tidal to a couple of days. And you can see the frickin' L poly swimming into the nitrocline, and you can watch the nitrocline get drawn down, and that's a smoking gun. So if we can get a quantitative story together, that's a nice thing, I think.
Yeah, that was something I was wanting to follow up on. So it is actually key that these things swim. That's what sustained this. Being someone not from the area, that wasn't obvious to me just from the name of the organism. Also, I'm a physical oceanographer. That is the key.
Yeah, I'm sorry. I should have said that at the beginning, because I also learned that pretty late in the game. So yes.
Yeah, I didn't make it clear in my talk either. I think I took it for granted.
Yeah, I'm just an ignorant northern physical oceanographer.
It's a talent that most phytoplankton do not have, so we tend not to think about it in most parts of the world.
Yeah, it makes it a lot more complicated. The biology, the species, really matters in this case. It's not your typical sort of physically driven system.
I think it's pretty sneaky what they do. Yeah, it's pretty good.
Yeah,
I also. Oh, go ahead.
I was just going to say that when you get into the details of Clarissa and I and some others at Scripps have a EcoHab proposal that talks about cellular mechanisms for toxicity production, and that feeds directly back into this story as well, because I think there's good evidence that it's concentration dependent, that the cellular upregulation of toxin production has lots of these relationships to density dependence and nutrient stresses, et cetera. And so this little ecological self niche making that kind of is a hypothesis that comes out of this feeds into that story of the DNA and the upregulation and the transcriptomics of toxin producing. So it kind of makes sense that they'd if they're going to be in this nutrient starved environment, and they're going to be at high densities, and they're going to be having to swim for their nutrients and stuff, that they would also poison the water column to keep anybody from competing with them. I mean, obviously, I'm just making up, waving my hands, but I feel like all this stuff must be related ultimately to the environment, and that there must be feedback.
I just wanted to mention one example of phytoplankton directly affecting albedo, and that is coccolithophores.
Mm-hmm. Indeed.
Absolutely, they have huge backscatter. It's really different. They're a really different group with the coccoliths that they make.
Yeah, so this has been awesome. Really, really good, authentic conversation. I wanted to also give Caren a chance to answer some of her questions. I know Chris, in the order Chris came in first with some interest in how her talk related to the Magnuson-Stevens Act. If Chris wants to hop on and ask his question.
Hi, Caren. Nice to meet you. I thought that was a fantastic talk, and I think the work has like really important implications for the rebuilding timeline specified in Magnuson. And I was wondering if you've sort of thought about that, or sort of thought about framing any of the work or extending it to sort of address some of those timelines.
Caren, you're on mute there.
Of course I am. Yeah, that's a good question. In terms of recovery times in regards to the Magnuson-Stevenson Act, we haven't really framed it that way, but looking at the different levels of fishing, we've looked at the levels of fishing and how that changes. So we've changed FLEP and looked at, MSY conditions versus overfish. So you could do that with the model for sure.
Yeah, it looked like at least for those rockfish life histories, a 10-year rebuilding timeline probably wasn't really possible.
Yeah, I mean, it really depends on the level of fishing that is the population is subjected to in the model.
Yeah, cool.
Yeah, and then Mark also, I think, had a question in there for Caren, if Mark's still around.
I'm still around. So Caren, first, my compliments. That was an interesting and potentially very useful analysis. I realize that you're focusing on press disturbances, but I'm wondering if you've considered moving in your future directions the integration of press with pulse, and the obvious connections to places like the North Pacific, or if you think about something like the duration of a heat wave. And you're quantifying the timescales of response and the life history parameters that influence those timescales for a given, let's say, a heat wave-like event. But how does that heat wave press disturbance interact with the long-term warming? You're on pulse disturbances, but how do those interact with the long-term press? And is a comparable duration pulse disturbance heat wave going to have the same effect in the background ocean state of 1980 versus 2000 versus 2020 and beyond? And so, so what do you think about trying to integrate press with pulse? Thanks.
I think it would be very interesting. The way we've approached it is definitely a very simple at equilibrium state with no press disturbance in there. But yeah, it would be interesting to be able to do that. I guess it adds in a different, another level of complexity in regards to what the survivorship is in regards to an overall increasing temperature or loss in habitat or whatnot. So yeah, it'd be something we'd need to think about a little bit more in terms of how we model that. But yeah, that's interesting. Sure.
Surely another level of complexity, but also another level of realism.
Indeed, I agree.
Great, and then I think we got maybe 5 or so more minutes for discussion if anybody has any pressing desires. I know there's a few other questions in there and a lot of responses going on in the chat, but I know at the end of EPAC, a lot of times we kind of have broader scale discussions on sort of interesting ideas of where the field is heading in the near term. I don't know if anybody wants to take the podium and comment on any overarching thoughts as if we were at EPAC.
I have a science question related to what Clifton mentioned and Al about the coccolithophores having really strong backscatter. Is this something that's parameterized in GCMs, or is it something that needs to be parameterized in GCMs? I mean, does it appreciably affect the outgoing, or I guess incoming shortwave out of the bottom of the mixed layer in the summer, for example? I mean, is this something that needs to be parameterized?
Yeah, a lot of these large blooms are North Atlantic. Barney Balch has been working on this forever, and the DIC product that you get, dissolved inorganic carbon product that you get from various NASA satellites, comes from that work. To the extent that people have integrated it into global climate models, I'm more ignorant on that side, but I'm assuming they have since it's been a while.
I think they're usually parameterized into the small phytoplankton subgroup. I'm not sure if they actually parameterize those effects, but Dylan, Kristen Crumhart, who was in my lab, she's a postdoc around here. She's actually put explicit coccolithophores into the CESM model. So she's run some simulations now with that explicit coccolithophore class, and I think it may, I don't know if it's run with the CMIP6 version of CESM, but it'll be included, and people can optionally run it, so it actually deals with those kind of effects.
But they're interactive, right? They're not just passive. Like there's a coccolithophore, it doesn't do anything, but does it interact with like the heat fluxes and things and the stratification of the mixed layer?
I think that's probably back to what other folks were talking about the biology feedback on physics. I think mostly in these climate models, the point of making it explicit is for the calcium carbonate cycle, because they're actually affecting that. And then to your point, this reflectivity issue. I don't know much about the feedback on the physics. I don't know if the BGC model couples back to the physical model much in these climate models, because maybe the effects aren't as appreciated, but I'm not sure.
Right.
Yeah, it's a good question. I don't know exactly how they do it either, outside of the fact that they obviously run some of these type of models for the carbon aspect of it. Whether that information is fed back in is, there's, we already know that the high frequency processes that are not represented well in the GCMs make a huge difference in the GCMs getting the answer right or wrong. And there's active efforts to improve that, and they have improved in the last 10 years. And is the next frontier coupling the biology back, getting the attenuation better, getting the optics better, getting the albedo better, and getting the interactions with the physics better. I don't know enough about it, but it sure seems like it's a major source of error in the current, at least the last generation of these models.
As a fun idea, several decades ago, James Lovelock suggested that the future would see more coccolithophores, and that would act as a thermostat on global warming. But that's just a fun idea. I don't know if anyone has really tried to quantify that lately.
Geoengineering via coccolithophores naturally sounds good to me.
That they're a thermostat that has been lurking in the background.
That would be a good solution. Coccolithophores to the rescue.
My understanding is paleo people have looked at that quite a bit.
Oh, okay.
Yeah, I just don't think it's in the kind of current versions of the models we run for forward projections. But I could be wrong about that too. Maybe the model or some of these more complex biogeochemical ones are looking at it, ecosystem models. I don't think Chris is online anymore, but he would know. Chris Edwards.
Yeah, I think in the